Alright, this is the Pilot's Handbook of Aeronautical Knowledge. This will be in Chapter 10. This will be Aircraft Performance. This will be 10-3. My favorite and your favorite, pressure altitude. Listen a few times. This will be good. Pressure altitude is the height above the standard datum plane, the SDP. The aircraft altimeter is essentially a sensitive barometer calibrated to indicate altitude in the standard atmosphere. If the altimeter is set to 29.92 HD standard datum plane, the altitude indicated is the pressure altitude. The altitude in the standard atmosphere corresponding to the sensed pressure. The SDP is a theoretical level where the pressure of the atmosphere is 29.92 Hg and the weight of the air is 14.7 psi. As atmospheric pressure changes, the SDP may be below, at, or above sea level. Pressure altitude is important as a basis for determining aircraft performance, as well as for assigning flight levels to aircraft operating at above 18,000 feet. The pressure altitude can be determined by either of two methods: by setting the barometric scale of the altimeter to 29.92 Hg and reading the indicated altitude, or by applying a correction factor to the indicated altitude according to the reported altimeter setting. Density altitude. The more appropriate term for correlating aerodynamic performance in the non-standard atmosphere is density altitude, the altitude in the standard atmosphere corresponding to a particular value of air density. Density altitude is pressure altitude corrected for non-standard temperature. As the density of the air increases, lower density altitude aircraft performance increases. Conversely, as the air density decreases, higher density altitude aircraft performance decreases. A decrease in air density means a high density altitude. An increase in air density means a lower density altitude. Density altitude is used in calculating aircraft performance. Under standard atmospheric conditions, air at each level in the atmosphere has a specific density. Under standard conditions, pressure altitude and density altitude identify the same level. Density altitude, then, is the vertical distance above sea level in the standard atmosphere at which a given density is to be found. The computation of density altitude must involve consideration of pressure altitude, and temperature. Since aircraft performance data at any level is based upon air density under standard day conditions, such performance data apply to air density levels that may not be identical to altimeter indications. Under conditions higher or lower than standard, these levels cannot be determined directly from the altimeter. Density altitude is determined by first finding pressure altitude and then correcting this altitude for non-standard temperature variations. Since density varies directly with pressure and inversely with temperature, a given pressure altitude may exist for a wide range of temperatures by allowing the density to vary. However, a known density occurs for any one temperature and pressure altitude. The density of the air, of course, has a pronounced effect on aircraft and engine performance. Regardless of the actual altitude at which the aircraft is operating, it will perform as though it were operating at an altitude equal to the existing density altitude. For example, when set at 29.92 Hg, the altimeter may indicate a pressure altitude of 5,000 feet. According to the AFM PHOAK, the ground run on takeoff may require a distance of 790 feet under standard temperature conditions. However, if the temperature is 20 degrees Celsius above standard, the expansion of air raises the density level. Using temperature correction data from the tables or graph, or by deriving the density altitude with a computer, it may be found that density level is above 7,000 feet and the ground run may be closer to 1,000 feet. Air density is affected by changes in altitude, temperature, and humidity. High density altitude refers to thin air, while low density altitude refers to dense air. The conditions that result in a high density altitude are high elevations, low atmospheric pressures, high temperatures, high humidity, or some combinations of these factors. Lower elevations, high atmospheric pressure, low temperatures, and low humidity are more indicative of low density altitude. Using a flight computer, density altitude can be computed by inputting the pressure altitude and outside air temperature at flight level. Density altitude can be determined by referring to table and chart in figure 10-3 and 10-4. Alright, we'll hold off there on density altitude. That's pressure altitude and density altitude. That was 10-3 and 10-4. See ya.